And this second video dealing with functions, we are looking at how we generally represent a particular function, and it's usually represented in the simple form f of x is equal to y. And of course, in most uh, max textbooks and chapters dealing with functions, the y is not written as such. It's but y is the output, and usually you have the mathematical or algebraic process which is written after f of x. So as we can see, I is the input value, and sorry, y is the output value, and x is the input value. And because it's x, this comes from a set element of x coming from a set, and you can randomly choose x. It simply means that uh, x is an independent variable, which simply means that y the value you get for y is based on x. So it simply means that y is a dependent variable. Now on may ask the question, why we must be choosing these two letters x and y? Why can't we choose something like f of a is equal to b? The reason for that is that now you have the coordinate axis, and of course when you graph the function and all, you notice that the x and y values have a particular meaning of it, and it refers to the coordinates of the ordered pair, that is dealing with the Cartesian coordinate system. So that's one key reason why x and y are the letters being represented here. Now let us look at some simple cases to get a clear picture. That is the input value y and the output value, the input value x and the output value y. And so suppose we are getting this ordered pairs, that is 2 4 3 9 4 16, and of course you don't have to be a rocket scientist to know that what we are dealing with here. The output is simply the square of the input value, which simply means that we are dealing with a square function, that is f of x is equal to x squared. What about the reverse process? For for input of 4, you're getting 2 9 3. It simply means that we are dealing with the square root function, that is f of x is equal to root of x. Now can we just write it like that and leave it off? Actually there's a key problem here, because when you are dealing with the real valued functions, that is functions between set of real numbers, naturally there isn't a solution for something like if your input is a negative integer, there isn't a solution for that. There isn't a solution for something like a root of -4. So in such cases you will have to mention about which values you should choose. That is, it would be root of x if x is greater than or equal to 0, and it would be undefined if it's x is less than 0. Of course, if we include the set of complex numbers, then naturally these conditions, there's no need to apply these conditions, because in complex numbers there's a solution for root of -4. Now let us look at a very interesting analog to this particular case, that is a function as a machine. Actually a function can be represented as a very simple machine. You have this box part where actually the process is going on. So there's a process, the mathematical process, the algebraic process going on here. Of course this is the input area, that is x is the input, y is the output, and suppose the mathematical process is something like so you're dealing with the f of x is x squared plus 1, then you'd be naturally getting for 2 you'd be getting 4 plus 1, that is 5. Naturally for 3 you'd be getting 9 plus 1, that is 10. So function can be represented as an analog, can be taken as a simple machine. And in such a thing, a key point to notice that is that you have the input and you have the output, and so if x1 is the input, naturally you'll be getting yn as the output. But the point here is that you can't have another output for x1. So you simply can't. So the case the second case is simply not possible. And what about a second input? Now here the interesting point is that x2 can actually give y1. Let us take the square function to prove this point. That is, square function is f of x is equal to x squared, and we know that f of 2 is 4 and f of minus 2 is also equal to 4. So you can see that a single input would only give a particular output, but a secondary input can also give the same output, but never can a single output give never can a single input give two outputs. So that's the key point, and that point was already mentioned when we stated about the rules which ought to be followed if a relation should be considered as a proper function. Thank you.